Let's start. I am Botezatu. I am head of BitYuri software. I'm glad to discuss today with our colleagues the interesting topic, algorithm of consensus. This topic is interesting personally for me because probably you know BitYuri produces equipment for mining bitcoins. So we work with proof of work. Secondly, we have Exonum project. In Exonum, we use Byzantine fault tolerance algorithm of consensus. I'm glad to share the details about these projects today, 20 minutes to 5 p.m. Also recently, BitYuri signed a strategic partnership with Emmercoin, and Emmercoin uses mix of proof of stake and proof of work consensus. So you see, even in one company, there is no single answer what algorithm of consensus is best of the best. I think it depends on use case, but let's discuss it with our participants. So let me introduce Trent McConaghy, founder of Ocean Protocol, Roman Oleynikov, IOHK, and Andrey Sobol, Pandora blockchain. I think we can start with a short intro of your projects. What type of algorithm of consensus do you use? And probably the most interesting, why did you decide to choose it? So Trent, please. You have, let's start with 5 minutes per person.
All right, I'll make this probably shorter for myself. I'm founder of Ocean Protocol, but also founder of BigchainDB. It's actually, both of those are under the same overall company, BigchainDB GmbH. And BigchainDB is a blockchain database, which means that it has database-like features for indexing and querying, but also acts like a blockchain in that you can issue assets and transfer assets. So within BigchainDB, we've actually, of course, it's decentralized. It needs to have consensus as well as address fault tolerance. And over the sort of 2.5 years that we've been working on BigchainDB, we've went through various evolutions of consensus protocols and monitored and kept track of the different proposals out there for BFT algorithms, as well as ones that address Sybil attacks on top. And kind of the way that we frame it is, you can have consensus for just fault tolerance, crash fault tolerance, and then you can address Byzantine fault tolerance, which is arbitrary malicious faults. And then on top of that, you can have Sybil tolerance, which is where people can enter and leave perhaps anonymously, and you have to account for the fact that when they do, they don't swamp you. You don't have sort of this attack of the clones where there's 1,000 of them, one person makes 1,000 copies of themselves and swamps the system, right? So crash fault tolerance, Byzantine, Sybil tolerance. Within BigchainDB, it's a permissioned chain, so we have to go for something approaching Byzantine. We don't need permissionless for the Sybil. Initially, we actually were leveraging directly the consensus algorithm of MongoDB, wrapping Mongo, and then trying to inject in ways to address the attack vectors. The way to address the attack vectors overall was to basically remove whenever there's a delete function that someone comes in, just not let that happen. Over time, though, we found that it's actually really hard to engineer that, and we learned this. And because we'd been monitoring the literature and whatnot and the software, then with BigChain, we actually are about to release a version 2 of BigChain that's actually using Tendermint consensus, which is a BFT variant that's partially asynchronous. And we looked at a lot of things out there, but for the goals that we needed, Tendermint is a nice trade-off because the software quality itself is near production ready. It's going to be powering Cosmos, for example, all this, and it has quite other nice properties too. In BigChain, we've set it up, however, such that as other new algorithms for BFT type consensus emerge and the software gets stable, then we will leverage those too in sort of this pluggable consensus. And there's a lot out there, right? Everything from Thunderella to Honeybadger and all of these. And we see that now academia has sort of switched on and started really working on BFT protocols and the permissionless protocols, such as these guys. That's really great news for BigchainDB, where we're not trying to invent consensus algorithms. We're just trying to leverage and make available the best in class. So that's kind of where we're at. I basically, in summary, BigchainDB has its own, it's using Tendermint consensus now, and within each node, it's actually a full instance of MongoDB, which has its own consensus, but that doesn't matter from a fault-tolerant perspective because you have the replicated state machine theory one level up. So I'll stop there. That's BigchainDB.
Okay, great, thank you. Roman?
Thank you. So IOHK works on development of cryptocurrencies. Main aim of IOHK to develop a new generation of cryptocurrencies. Our main product is Cardano cryptocurrency, and in heart of Cardano we have Ouroboros consensus protocol. So currently we published 2 versions of Ouroboros, and we're working on several further versions of Ouroboros that will be published later. So we started from the beginning to look at the proof-of-stake consensus. So if we look to traditional proof-of-work consensus, we can say, of course, it can be bound to some physical resource, which is limited. It can be like energy or something like that. But if we look to the scale with which Bitcoin or other cryptocurrencies spend energy, and we get huge values of energy just wasting for producing blocks. It's very different cost per transaction. I got different estimations per transaction for Bitcoin from 5 kilowatts to 200 kilowatts for one Bitcoin transaction. It's a really huge amount, and of course it's a useless wasting of energy. From the beginning at IOHK, we started to work with proof-of-stake consensus, and finally we developed Ouroboros. Ouroboros is the first provable secure proof-of-stake consensus. We presented this paper on crypto in August previous year. It's a leading world conference on cryptology. We got independent expertise of it, and it leads to Cardano cryptocurrency that works right now. Here we don't need useless wasting energy. To produce Cardano blocks, it's enough to have one PC, but we guarantee the same level of security, even more levels for some conditions, more level of security than traditional proof-of-work algorithms. Of course, there are lacks of traditional proof-of-stake approach, like long-range attacks and so on. And of course, there are arguments from proof-of-work side that it's much more complex to build such a chain that repeats all the transactions, that build alternative chain for Bitcoin and so on. But if we look to the cost of attack to real-world Bitcoin, when we really need to use checkpoints, for example, most people use SPV client, light clients. They don't use full blockchain. They just check current version. Or if we look to the attacks which are bind, for example, we attack not only Bitcoin blockchain, but we attack underlying infrastructure. For example, the cost of breaking into computers that run this protocol and so on. We will get much smaller values than just create an alternative blockchain. So, and in this case, in these conditions, as for my opinion, and not only my opinion, the proof-of-stake approach allows us to get really efficient solution with a high level of security. Okay. Thank you.
Thank you.
Pandora blockchain tried to create open, decentralized, and censorship-resistant AI market. So Trent say they don't invent a consensus algorithm, and we try to invent consensus algorithm. So for validation of AI and machine learning calculation, we create a protocol, Prometheus protocol. It's sort of proof of works, but we need no reason to check all work, all calculation for Prometheus. It's our top level of protocol. The bottom level, it's proof of reputation. Proof of reputation, it's sort of proof of stake, but if in classic proof of stake you can send your money to other participant, to other user of blockchain, and other user blockchain get the stake and can create new block in blockchain. In our paradigm, you cannot send reputation. You can get reputation only if you will calculate network, so it's get more security as we think, because all people who will validate main chain, they will use it. They will use our blockchain as people who calculate AI and so that's all.
Okay, thank you. I'm as a host, I would like to ask the first question, and then you will be welcome also to ask our participants. So my question is simple. What do you think, how important is consensus compared to other parties of blockchain system, for example, smart contracting? And is it possible to build good solution with sub-pair consensus?
To me, I would recast the question as, does scale matter, right? And consensus algorithms and scale are intimately related. If you have a consensus algorithm that doesn't scale, or that makes severe trade-offs of using electricity or whatever, then your system itself won't scale. That said, even if you do have a really fast algorithm for consensus, it doesn't mean you fully solve the scale problem, right? For example, if your throughput is now at, say, 10,000 transactions per second, well, that needs to get stored somewhere, right? So you still need to solve the data storage problem. Otherwise, everyone running a node is going to be having to, have another gigabyte every few weeks or something, right? So to me, overall, scale matters, and when I say scale, I mean capacity of how much it can store. I mean throughput. I mean also latency. Although I guess you could call that speed. But in general, these sort of characteristics of performance that you expect out of a distributed system, whether it's a traditional distributed system that's only fault tolerant, or whether it's a blockchain style one that adds the Byzantine faults or the Sobol tolerance. So it matters a lot, and how much does it matter compared to the other things? Well, it depends what features you need, but we are seeing that a lot of blockchain adoption of real applications are being held back right now, most notably in the Ethereum community, right? People who have been building dApps for 1 year, 2 years, 3 years, they're trying to ship and they can't because scale is killing them, right? So there is actually pain out there. The good news is some people have been seeing this for a while, and there's actually a lot of solutions emerging, not just with respect to consensus, but other ways to address it too, things like plasma sidechains, throughput, et cetera. So this is all towards the goal of scale.
Okay. Thank you. So, as for my opinion, consensus is the heart of the system, and having weak consensus, we cannot build a strong and productive system and so on. It's our basement, and if the basement is weak, everything else will fall. So we need to build a really strong, really secure consensus, and only after that we can build anything else over this consensus. So if we take IOHK approach and Cardano, we strictly divided these layers. We have a settlement layer, it's consensus layer. We verified it very, very well, and after that we started our cryptocurrency. The next level will be computation level, will be smart contracts and so on, but these layers are independent. And the critical condition for running smart contracts, it's a very strong consensus. So it's really necessary condition.
I think consensus it's platform for other feature in blockchain, smart contracts, scalability, and other. Because if you get some problem in consensus, you get something like Neo a few weeks ago that they stop blockchain because they cannot good implementation. They cannot a good implementation of BFT. One node of Neo stop all blockchain. So if you had any error in smart contracts, only user who use the smart contracts get problem. If you have error in consensus, all blockchain user get problem and very, very big problem.
Okay, thank you. I see here a lot of smart people, so I'm sure that you have questions to our participants. So please introduce yourself, probably the name of the company. Who have a question?
Если можно по-русски, вот ты переведешь. Ксения, Блоксофт, смотрите, а вы рассматриваете идею консенсуса по смене консенсуса?
So I will translate it in English. So the question on governance. So how can we, do we have any ideas how to change, how to have consensus on changing consensus? So I may start with this question. Yes, IOHK really works with it. We have two different directions. First direction is treasury. We work in a treasury that allows self-sustainable cryptocurrency development. So besides issuing new blocks, we need software, we need research, we need marketing, and very many other things for successfully running cryptocurrency. And if we want to have centralization in one company that runs the cryptocurrency and or some cryptocurrency depends only one team, to have fully decentralized solution, we need such self-sustainable system. We work on it and we develop very interesting solutions. For that, we will present them, we are going to present them this year. So besides it, returning to the question on governance, yes, we need to take consensus on how to change consensus. There are different approaches for it. For example, it was, as far as I remember, Tezos cryptocurrency, at least project for good change in consensus. They have formal procedure how to switch from one consensus to another consensus. We took a little bit different direction, but also Cardano will have governance for their consensus for the whole properties of cryptocurrency. We'll have formally proven mathematical methods that allows majority, maybe just majority, maybe two-thirds majority, just to make decision, and this decision will be automatically taken into effect. So yes, we are working on it, and we will have mathematically proven tools for it, and they will be run in Cardano.
I think just now we have only two worked approach of consensus, of governance consensus. First approach is Bitcoin maximalist approach. They say, okay, we need no any big changes in the main chain, in top layer. We can create other layer, second layer, for example, Lightning Network. And after Lightning Network, we create another and another and another layer. And main protocol, we cannot change without any reason, without any very, very strong reason for this change. And another approach, it's like Vitalik Buterin. Okay, we hard fork. Every 10 minutes, another hard fork. I have no idea which of this, which way it's right. I think we need mix of this. Of this government approach, because many changes it's bad, and zero changes it's bad.
Overall, I see it, the challenge is, the question, I frame it as, how do you upgrade or update the protocol, right? What are the rules for updating the protocol? That's really the heart of governance question. And it can be times where it's very obvious there's a bug that needs to get fixed, so then everyone is fine behind that. But then there's other times where you may want to make a change that could be much more controversial, right? And there's sort of a spectrum to solving this. One of them is where you have the hard forks, like was discussed. And the other one is where you have, that's one extreme, so you don't even have anything built into the software itself, you just have hard forks happening. And the other extreme is on-chain governance, right? And there's shades of gray in between. And so Bitcoin and Ethereum, they all have hard forks. The communities have different philosophies, approaches, ways of thinking about the hard forks, but really that's the main. And then on the on-chain governance, a year ago, I've actually went back and forth on this myself in terms of thinking, like opinions, but I'll just simply give data points. There are at least 2 systems out there running for several months where it's been working. Dash is running, and they actually have Dash as a dashboard where people can submit a proposal, and then the community votes on it with stake, etc. And you can see that there's actually a lot of changes have gone through, and some get voted down, some get voted up. That's very nice. The other one that's out there that's very well thought out is Decred, and they actually have it set up where you have a price in order to vote. They call them tickets, and so in order to vote on a given proposal, you have to buy a ticket. And what's amazing, in the 6 months plus that Decred has been live, the price of a ticket has been going up, which means that people are starting to value governance more and more and more. And I think that's really great. I guess there's one final way of thinking about this all too. So you've got hard forks, the spectrum to on-chain governance. There's an even greater extreme, and that is the token is only for governance, and that's all. And for example, if you want to have governance on, a stablecoin where it's all about the monetary supply, then that's probably a really good thing where the token's only for governance. And a great example for that is MakerDAO, right? So to summarize, and that just went live recently, to summarize, on-chain governance, it's coming. There's actually working projects out there that have had some nice success. We'll see if how things go.
The problem with consensus algorithms and actually governance too, especially in Dash, is centralization of money in hands, or let's say in Dash is centralization of master nodes. Well, in Decred we'll also have centralization of governance because people with large stakes can buy a lot of tickets, right, to vote and change the governance in the way they want. Change the consensus in the way they want. But also, the problem in consensus algorithms is also decentralization. So in some protocols, having people with large stakes will lead to centralization of power and a large influence on the blockchain. So what are your opinions on solutions to decentralization?
I'll give a couple examples. First I'll say that's a great question, and I think it's a great concern, and I don't think there's any magical solution right now. Interestingly, with things like Bitcoin, I've had conversations with miners where they had the opportunity to actually get 51% mining power, and they didn't take it because they knew that if they took it, it would kill the value of the network, right? So basically Bitcoin would drop like crazy, and then their business model would go away. So there's actually an implicit economic constraint not to take over the network, potentially.
Can I just interrupt? I think Bitmain has over 51%. It's just split in different mining pools, so they kind of hide their true hash power in Bitcoin.
That's a good point. And China too has the majority. So, yeah, but somehow, so there is some implicit thing happening, but of course that's even fuzzy, right? Another, I forgot the other example, so I'll leave it at that.
Trent, you talk about incentivization and game theory. So that's that. If that anybody have big hash power, they cannot do double spend or other attack. But it's not BFT argument. So if they want, they can do it. So, and I think just now we have no good solution for how to fix it, because all protocol PBFT or any other BFT and proof of work and proof of stake, we can kill using 51% of hash power or stake power or other.
Actually, riffing on that too, you're absolutely right. Ian Grigg recently mentioned all public consensus algorithms, they come reduced to proof of resource, right? So that's actually the big challenge, right? One thing that some people have been doing is, they call it quadratic voting, or in Ocean we actually have log of voting. So basically with log, if I have 10x more compute power than you, then I only get 2x more vote. And it's sort of a balance. That said, well, the main miners just get rid of that log and just put it linear again, right? And actually, once you do anything that isn't linear, then you actually need better proxies on identity, right? So, but that has its own challenges. So it's another way to help balance, and we'll see if any of those have success. They're trade-offs, though. The wonderful thing about something like Bitcoin, you know, it doesn't care about identity. It's sort of like one electron, one vote, in a sense. So that's it.
I can also add, I completely agree that for some business models, it's not profitable, it's not an efficient strategy to take control over the system. It's much better to split system to minimize risk or something else, but not to take control over 51% of hashing power or 51% of stake and so on. So it's really within the business model. It's the first view on it. Another view on it that it's of course not only consensus problem. It's the question to the whole system, and here we need to take into account also cryptonomics views, cryptonomic question, game theory analysis, and look to the different incentives. It's also another very different and very interesting direction for researchers, and the researchers are going into this direction. But we also have here approach for technical solution. We have another generation of consensus protocols that build on a cyclic directed graphs. So there are several examples of such protocols. Many of them have very good properties, and it allows to avoid centralization. For example, if you run modern Bitcoin and if you mine it, you have a really big problem if you don't join some mining pool. It's very likely that your equipment will work for years and won't give you any block. And in this case, you spend your money for equipment, you spend your money for electricity, and got nothing. To make this model profitable, you must join some mining pool. But if we change consensus protocol, when it is generated not only 144 blocks per day like for Bitcoin, but if tens of thousands or even more blocks or transaction or some other units are generated during one day, then you don't need to join the pool. You will work by yourself and you get the same profit. So for this centralization problem, making some conclusion, we have some business rational strategy, some balance. We have undergoing research for creating incentives, and we already have at least theoretical solutions to allow decentralization. Okay, thank you.
My name is Roman, and CEO of for a 2.0 solution company and CTO of Remi. And one question is about inter-blockchain consensus. What do you think about this approach? In my opinion, our next task, how we can make inter-blockchain communications. If we have two different blockchain, for example, and we have made consensus between them, how we can do this consensus?
Oh, we don't need consensus, so we can use atomic swap.
The way I like to think of it, you might want to connect networks in terms of value, in terms of data, in terms of value, or in terms of state. So for data, we have something that's been around a long time called TCP/IP, right? It connected ARPANET with Cyclades, et cetera, back in the day. And one level up for connecting in terms of value, this is, like you mentioned, and this is built into things like Interledger Protocol, Cosmos, all of these, right? So there's a few there. And then one level up for connecting networks of state, probably the best example right now is Polkadot. Where you can have a smart contract that kind of talks to other stuff. It itself, though, relies it doesn't have amazing scalability properties the way that Interledger or TCP/IP has. So it's all pretty early stages, but those are ways to think about it, I guess. And there's also, of course, all the layer 2 protocols, which ironically also leverage state channel technology, right? Crypto escrow, whatever you want to call it. So. Generally, though, the whole point of having different networks is that they don't have to maintain all of everyone's state, right?
Yes, I can also add that we can find consensus between two blockchains. To transfer value from one blockchain to another blockchain, to have the security guarantees within these blockchains. So it's possible. We have several approaches to implement it. Of course, the most interesting is fully decentralized. And currently, so if speaking about only HK, we are working on sidechains technology that allows transfer value and information from one blockchain to another blockchain, and to provide security guarantees that if one sidechain will be broken for some reasons, will be completely broken, then it is not a threat for the rest of the network. We have main chain, we have side chain. If something goes wrong in the side chain, it doesn't influence main chain. We have some loss in coins, but only in coins which was connected only to the side chain. Okay. Thank you.
And I will add, if you Bitcoin maximalist, you can read about drive chain. It's a sidechain solution where miner can vote to transfer money to sidechain.
Any more questions?
Hello, I'm Tobias from KI Decentralized, and I'm dealing with different blockchain platforms as well, and had a look at different consensus mechanisms. And what I figured out is especially those that are fast on finality require a total connection, so they don't scale at all in the number of nodes. What's your take on this?
If we look to traditional consensus algorithm, for example, in Bitcoin, yes, we really have a strong problem. We need to have extremely fast network, and in this case, we have some scalability. Or if we have network with delays, even with not big delays, these delays may significantly decrease security of the network. Yes, we have trade-offs for conventional consensus, but a new generation of consensus protocol depends much less on it. Even if we are speaking about pure BFT protocols, BFT in strong sense, when we work over asynchronous network, we are speaking not consensus about cryptocurrencies, we are speaking about consensuses for other purposes. In this case, 2/3, it is required that 2/3 of nodes must be honest, must participate, must be online, and so on. Even in this case, currently we have a few really good full BFT consensus protocols that provide us high scalability, and they provide high throughput, and there are enough fast. So it's Algorand, it's hash graph, and I really like their properties. So their limitations, at least in their current versions, they are developed for permission network. They are not for public network and cannot be used in cryptocurrencies like they are presented right now. There are very many tasks behind it to be sure that they can be securely used in cryptocurrencies. But if we look into permissioned network, we have a really good, highly scalable, very high throughput consensus, full BFT consensus algorithm.
Just as a quick aside, if you have a nice BFT algorithm, there's at least one recipe to convert that to permissionless, and that's using DPost, right? Delegated proof of stake. And that's basically how Cosmos is transforming Tendermint consensus, which is BFT, towards permissionless Cosmos, right? Where they have, in their case, 100 nodes running together, right? EOS is doing this, et cetera. There's another way to view this all, and this comes down to the CAP theorem, right? So this is a classic result in distributed systems theory. Consistency, availability, and partition tolerance. Pick any two, right? And you can rephrase this, though, as in the event of a network partition, like split brain, are you going to favor availability or consistency, right? And you would think that, given that you've got blockchains that are storing value, that you probably don't want you want to prevent double spends, right? So you don't want your Bitcoin to be flying two different directions. But almost hilariously, Bitcoin actually favors availability, and does the theorem in all of these. And it seems that there's an implicit economic incentive, once again, where even though it's favoring availability, it's consistent enough for people to value the network at more than $100 billion, right? So in theory, Bitcoin shouldn't have worked, but in practice it did. So it's actually a completely new result for CAP theorem.
The main problem in public consensus like proof of stake or proof of work, we have no finality. We have only probability of finality, because strong finality we can get only in BFT consensus algorithm like like PBFT, like hash graph and another. So it's problem, and I think we have no good solution for this, because strong finality we have only in Grave, I think.
Yeah, but especially Hashgraph, I like it as well, but there I read exactly that it doesn't scale in the number of nodes. So then you have to put something on top if you want to use it in larger networks where you have lots of participants. And this is where I see where blockchain makes sense if you have lots of participants.
So if you are speaking about Hashgraph, they have very good scalability. So we have n log n scalability overload for Hashgraph. And it's very good parameter. For example, for PBFT, we have quadratic overload. Here we have almost linear. It's a really good solution. If we switch to another type of network, if we work not in fully asynchronous network as Hashgraph, but switch to synchronous network like Algorand, where delivery time for messages are limited. They can be big, but limited. In this case, we can get even more interesting properties, even less load for the network. So there are good solutions, but currently they are for permission networks.
Thanks.
Thank you.
I think we are out of the time, but probably we have a time for one last question.
Hello. Do you know RSK network, rootstock, you know? What do you think? This is a good solution for Bitcoin? Or it's like crunches?
I think it will be a good solution if we implement drive chain to Bitcoin, because just now it's federated, because just now federation will control your money if you will use rootstock, and it's not a good idea, I think.
Rootstock implements smart contracts, and it's really needed for Bitcoin. So I'm not very familiar with details, but I really like the idea that smart contracts should appear in Bitcoin. Looking into technical details, of course, we can discuss consensus algorithm, so modified Ghost that is implemented there. Of course, there are better alternatives, but they have selected practically verified solution. It's not perfect from theoretical point of view, but it's practically verified. So that's great that we have a very good chance to have smart contracts on Bitcoin.
To me, actually, what's most interesting about RootStock and also WitNet is it's actually a different trick for connecting networks. So instead of having something like a state channel to connect or some other trick like that, instead you have two processes running side by side in the same box. And so RootStock does that for Bitcoin, and then now they're going for Ethereum as well. WitNet is doing a similar thing to connect basically a data, in its case, it's doing a decentralized data oracle or data availability network. So you've got Geth running side by side with a WitNet process that has its own WitNet net, basically. And it's wildly simple to think about, but it's working. And we've seen RootStock adoption with the miners go up very quickly. So and WitNet is a very cool design. So any of you who are thinking about connecting networks, it's just another tool in your toolbox.
Okay, thank you for the questions. Thank you for attending this discussion. And of course, thank you our participants for these great answers.